Hi, Algebra 2. In this lesson, you are going to get the final tool for your toolbox in solving quadratics, and it is the quadratic formula. Here we go. Here is the quadratic formula. You're not going to be expected to memorize this. You can put it right on your note sheet for quizzes. We get it by completing the square from our standard form. We're not going to go through how to do this, but it can be used to solve any quadratic, even those with complex and imaginary solutions. When you use the quadratic formula, you do need your quadratic to be in standard form so that you have an A, a B, and a C. And we're going to start by saying x equals, and here's our formula up here in the corner, negative b, so that's going to be a negative 16 in this case, because b is negative 16 here, plus or minus, that's where we get our two solutions, the square root of b squared, so negative 16 squared, minus 4 times a, which is 2, times c, which is 27, all being divided by 2 times a, which in this case is 2. The rest of it from this point on is simply just simplifying this, and our biggest thing we have to be careful of is negatives. So here we go. The first part we have negative 16, so that'd be a positive 16 plus or minus. Underneath the radical, we have the square root of, or 16 squared, that'd be 256, minus 4 times 2 times 27, which is 216, all being divided by 4. If I keep simplifying, I'll have x equals 16 plus or minus, underneath the radical, we have 40, all being divided by 4. And now we're just going to keep simplifying here. Square root of 40 can be broken up into square root of 4 times the square root of 10 times 4, or excuse me, divided by 4. And finally, we break that up. Square root of 4 is 2, and there's our answer. Remember, this does include two solutions. It could be 16 plus 2 times the square root of 10 divided by 4, or 16 minus 2 times square root of 10 divided by 4. Now you can leave it like this, that's just fine, but if you check the key, they're going to simplify it even one step further. They would take everything here divided by 4. So 16 divided by 4 is 4. And then over here, 2 divided by 4 is going to be 1/2, or you'd be left with the square root of 10 over 2. Now, if you leave it like this, that's just fine for me, but if you check the key, this is what it would look like. Okay, here's everything filled in to your quadratic formula for your A, B, and C. Now keep on simplifying and start again when you're ready. Now in this one, my first step of simplifying, I had 3 squared, which is 9, and then the negative 4 times 1 times negative 7 is a positive 28. And I keep simplifying. Underneath the radical there, I would have 37. So my answer would be x equals negative 3 plus or minus the square root of 37 divided by 2. Now, if you graph this on Desmos, if you graph this, you would see some real zeros, right? This is a real number, but they're going to approximate the decimal. In our answers, you just leave it exact like it is. Okay, at this point, I've plugged in everything for my A, B, and C into my quadratic formula, and I've started simplifying. Here, I'm simplifying under the radical, same right here, and I just have to keep on simplifying. From this point, I broke up the square root of 24 into the square root of 4 times the square root of 6. Square root of 4 is 2. And then here, I did divide everything by 2 to simplify it even more. 8 divided by 2 is 4. 2 divided by 2 is just 1. And so I end up with 4 plus or minus the square root of 6. Okay, in this one, I've started out by just putting everything in for my A, B, and C into my quadratic formula. And as I start simplifying here, I'm going to start to notice something underneath the radical. Oops, I'm going to make this 8. Underneath the radical, I see that I'm going to have 9 minus 32, so I'm going to have a negative number underneath there, which is going to tell me that my solutions are going to be imaginary, or I'm going to end up with complex numbers. So here's what I have so far. So as I keep simplifying, I'm going to break this up into the square root of 23 times the square root of negative 1. The square root of 23 doesn't split up into anything else. And so I'm left with square root of I times the square root of 23 over 8. So here's my solution. If you look in the book, you would see them split this up into -3/8, divide that part by 8, plus or minus the square root of 23/8 times I. It's just another way to write it. So here's where the quadratic formula can be helpful, no matter what your solutions are. If they're real numbers or imaginary numbers, the quadratic formula will work. Okay, I've filled in everything here for A, B, and C in the quadratic formula, and now I'm simplifying. Underneath the radical, I notice I'm getting a negative. I would get -95. And as I keep simplifying this, I would just write this as -95I over 6. So 1 plus or minus the square root of 95 times I over 6. In the book, they will divide everything here by 6. And so you'd end up with 1/6 plus or minus the square root of 95/6 times I. Either way is fine for me. You've probably already noticed that what we end up with underneath the radical there is important in telling us what kind of solutions we're going to end up with, real or complex. So we know down here, what's underneath the radical there is called the discriminant. And down here in the table that's in your book, it's telling you that if that discriminant, b squared minus 4ac, is greater than 0, that you're going to end up with 2 real solutions. If the discriminant is equal to 0, you're going to end up with 1 solution, meaning your graph only touches the x-axis once. And if it's negative or less than 0, then there's going to be 2 non-real imaginary solutions. In this problem, they're telling us just to find the type and number of solutions for this equation. So first thing, I need to write this equal to 0. So I subtracted 12x from both sides, so I get it equal to 0 so that I can use the quadratic formula. And if I'm only looking at what kind of solutions I'm going to end up with, I can just use the discriminant. And so I would have -12 squared, that's my b, minus 4 times a times c. As I simplify this, I see that it ends up being 0, which means that I'm going to have 1 real solution. This is going to touch the x-axis in one spot. Okay, so in this one, we just want to know the type and number of solutions. Again, I need it equal to 0, so I'm subtracting 12x from both sides so I can have my a, b, and c. Here's the formula for the discriminant, the part underneath the radical. And so my b is -12, -12 squared minus 4 times a, which is 1, times c, which is 40. And as I keep simplifying, I'm going to see that I end up with a negative number. This is going to be -16. So this is going to have 2 complex solutions, which means we're going to have imaginary numbers involved. So in this one, I again set my equation equal to 0, use the discriminant, fill in what I know. So -12 squared minus 4 times 1 times 30. And when I simplify this out, I get a positive number. Now that's the positive number that's going to be underneath the radical there. Since it's positive, I know that there's going to be 2 real solutions to this quadratic.